Okay, hello. Hi, algebra students. This video will go over all of the study guide problems that I've created, pulled out from your OneNotes, and it'll just go through different topics, different kind of problems that you might see on your test. So I'm just gonna go ahead and jump into it. Actually, I'm gonna do that. Okay, so what we're gonna do here, topic 1 is solving quadratic equations by factoring. So the first thing that we need to do when we're solving a quadratic equation is we need to set the quadratic or the expression equal to 0. Right now, we don't have that. It's equal to 3x minus 1. So we need to get this whole equation equal to 0. We need to move some things around. So the first thing I'm going to move around is, it doesn't really matter what you do first, as long as you do everything the same on both sides, right? That's the rule of algebra. Do one thing to one side, do the same thing to the other side. So if I want to get this side equal to 0, what I'm going to do is I'm going to move these terms over to that side. And I'm going to do one at a time. So I'm going to add 1 to both sides. Why I'm adding 1 is because I see subtract 1. To undo the subtraction of 1, I'm going to add 1. That will cancel out, and I'm just going to combine my like terms. X squared stays the same, subtract x, and instead of negative 46, I added 1, so it's actually now negative 45. And that's equal to 3x. The next bit is I need it equal to 0. Right now it's equal to positive 3x. To get rid of positive 3x, I'm going to subtract 3x from both sides. Okay? And the positive 3x and the negative 3x cancel out. So now we have x squared minus x. Oh, no, sorry, not minus x anymore. Before, it was negative x, and I subtracted 3x, so now it's negative 4x. Because these were like terms, just as those were like terms. And subtract 45, and it's equal to 0. Now I can go ahead and factor. We've been practicing factoring for a little bit now, but we'll go through this anyway. What I'm going to do to factor is I'm going to create my x, my big X. And what I do with my big X is I take my b term, and I'm going to put it down here. I think it's kind of arbitrary where we put everything, but I'm going to put negative 4 here, and I'm going to take my c term. I want a different color. My c term, and I'm going to put it right there, negative 45. The thing that I now need is I need two numbers to go here and here. These two numbers are going to multiply to negative 45, and they're going to add to negative 4. Notice that I carried the negative signs with my terms. That's super important. We know that. The negatives matter. The fact that we're multiplying to a negative number means that one of these numbers is going to be negative, and one of the numbers is going to be positive. Because the only way we can multiply to a negative number is multiplying a negative number times a positive number. So I already know one's going to be negative, one's going to be positive. And that also makes sense because we have to add to a negative number. There's no way we can add two positive numbers and add up to a negative number. So we know we need to add to a negative number. So what I'm going to do is I'm going to ask myself, well, what are the factors of 45? Oh, so factors of 45, and remember factors. Well, we're really talking about factors of negative 45, but factors of negative 45 and 45 are the same, just one needs to be negative and one needs to be positive. As a reminder, factors are numbers that multiply together to get the number that we're trying to produce. So what pairs of numbers multiply together to produce the number 45? I know 1 times 45. I know, what else do I know? 9 and 4. So 9 times 4. What else? 15 times, is it, wait, sorry, it's not 9 times 4. Sorry, it's 9 times 5. And I think, oh no, there's also, sorry, 3 times 15. I thought 15 was 1. Okay. Those are the only factors of 45. And since it's negative 45, one of those numbers needs to be positive and one of those numbers need to be negative. So it could be negative 1 times 45, or it could be negative 45 times 1. That's how we'll produce negative 45. Remember, I said we're also adding to negative 4. So when we look at these numbers, 1 and 45, 9 and 5, 3 and 15, which pair of numbers are 4 apart? Well, 1 and 45, if it was negative 1 and positive 45, there's no way that will add up to negative 4. Even if it was negative 45 and positive 1, no way. So it's not that one. 3 and 15 are also too far apart, but 9 and 5 are really close. So I know I'm going to pick 9 times 5 to make 45. The only thing I now have to decide is it going to be negative 9 or is it going to be negative 5? The fact that I'm adding up to a negative 4 means that it needs to be negative 9 because we need a larger negative number to stay in the negative values. So I'm going to write negative 9 here and positive 4 there as negative 9 times 4. No, why do I keep saying 4? I'm sorry. It's not 4. It's 5. I'm sorry. But negative 9 times 5 is negative 45. And negative 9 add 5 is also negative 4. So we have completed both of these requirements, as we need to multiply to our C term. Remember, this is our C term. We need to multiply to our C term and add to our B term. So those are the factors that we're going to put in our parentheses sets. X minus 9, because it was a negative 9, and X add 5, because it's a positive 5. That is the factored form of this equation, x squared minus 4x minus 45. I'm going to write that one more time. X squared minus 4x minus 45. That was equal to 0. And the factored form is x minus 9 times x minus add 5. Sorry, x add 5. We're setting it equal to 0 because that's how we solve for a quadratic or solve for any equation. We set it equal to 0 because we want to know when the equation, when the graph will hit the x-axis. So what we're going to do now is, if we remember the zero product property, if this term or if this quantity, whatever x minus 9, if we set that equal to 0, then the whole expression becomes true and is equal to 0. Because if this was 0, 0 times anything is 0. Same thing for the other side. If we set this quantity, x plus 5, equal to 0, then this becomes 0. If we solve for whatever x plus 5 is equal to 0, if we solve for x and set that equal to 0, then the whole expression becomes equal to 0 and true. So that's why we take our parenthesis sets, our two quantities in parentheses, and set them equal to 0 in two separate equations, and we solve for x. So let's focus on the first one. X minus 9 is equal to 0. Well, to get x alone, we need to add 9 to both sides. When we add 9 to both sides, the negative 9 there and the positive 9 cancel out, so we get x is equal to 9. Over here, we have x add 5 is equal to 0. Well, to isolate x, as in get x alone, we need to subtract the 5 that's being added to x. And we do that to both sides. So when we have the positive 5, subtract that 5, they cancel out, and we get x is equal to negative 5. So these are our two solutions. X is equal to 9 and x is equal to negative 5. If you were to plug those numbers, either 9 or negative 5, back into the original equation here, you will see that they're equal. Like if I put 9 squared subtract 9 minus 46, that will be equal to whatever 3 times 9 subtract 1 is. Or if you put 9 back into this equation or this equation, it'll be equal to 0. Same thing with negative 5. That's one way you can check your answer, and that's how we solve quadratic equations by factoring. Okay, the next topic is solving quadratic equations using the quadratic formula. So I realized I didn't give myself any room here to write the quadratic formula, so I'm going to move this down a little bit. This is the quadratic formula. Quad formula. It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And you might be asking, what is a, what is b, what is c? Well, that's where we have to talk about the standard, also known as general. All right, general form for quadratic equations, okay? So we have to remember, what is the standard or general form for quadratic equations? That is ax squared plus bx plus c. This is where we have a is whatever's being multiplied to x squared, b is whatever's being multiplied to the x term, and c is the term, the constant that has no variable being multiplied to it. So that's where we get our a, b's, and c's that we use and plug into the quadratic formula. And also, it's really important to know if it's a positive or negative sign. So let's check it out with our problem number 3. We have the quadratic 8x squared subtract 2x subtract 15 is equal to 0. So what we're going to do is we're going to have to decide what is A, what is B, and what is C. Not really decide, but like, you know, figure out. So A, the value of, the value of A is whatever's being multiplied to the x squared term. Here's the x squared term. The value of A is the coefficient, which is 8. Okay. For B, the value of B is whatever's the middle term, whatever's being multiplied to the x to the power of 1. Here's that term, the middle term. And it's not just 2, but it's negative 2 because it's a negative 2x, right? X itself is not a negative variable. It's negative because there's a negative 2 being multiplied to it. The last one is for the C term. The C term is the term that has no variable being multiplied to it. In this case, it's negative 15. negative 15 because it says subtract 15, which is a negative 15. Okay, what we're going to do now is they already set up the quadratic equation really nicely for us, as in b goes here because it's negative b plus or minus b squared minus 4ac times 2a. So I'm going to go ahead and plug in what we know for these letters, as we just identified a, b, and c. Well, b is negative 2. So I'm going to put here again, negative 2. A is 8. So I'm just plugging in everything that I know. C is negative 15. And A again down here is 8. So X is equal. The thing right here, negative b. The actual part of the quadratic equation says it's negative b. Well, our b is already negative 2. So negative b is actually just 2. As you can see right here, there's like the negative 2. Well, two negatives make a positive, so I'm just going to write that as 2. 2 plus or minus the square root negative 2 squared. This right here, negative 2 squared is negative 2 times negative 2. Two negatives make a positive, right? And 2 times 2 is 4. So that's 4. All right. So negative 2 squared is 4. Now, the whole negative or subtract 4ac, I like to do all of that in one big parenthesis because sometimes there's a negative number and it can get mixed up. We have 4 times 8 times negative 15. Well, 4 times 8 is 32 times negative 15, which I don't know what that is. Here's my calculator. 32 times 15. But it's negative 15, and if we have one positive and one negative, that's negative 480. Negative 480 is when you multiply 4 and A and C. And this is all over, well, 2 times 8 is 16. Okay, next little bit, we're just cleaning things up. You remember your PEMDAS, and that's how we're going to clean things up. X is equal to 2 plus or minus the square root. And this thing here, we have 4 subtract negative 480. Well, like I just said, two negatives make a positive. So when you subtract a negative, we are adding. So I'm going to write 4 add 480. And this is all over 16. Okay. I need more room. Okay. X is equal to 2 plus or minus the square root. 4 plus 480, well, that's 484. Remember, this is all over 16. And now we have to find out what is the square root of 484. And if we don't remember what that means, what we're asking ourselves is what times itself will give us 484. So like the square root of 16 is either plus or minus 4, because 4 times 4 is equal to 16, and negative 4 times negative 4 is equal to 16. So we're asking ourselves, what times what is 484? You can use a calculator or you can ask Google, but the answer is 22 or negative 22. So here we're going to have, I'm going to bring us up over here, and we're going to have X is equal to 2 plus or minus 22, because the square root of 484 is 22, all over 16. The last bit to solve our equation is we need to separate the plus or minus into two equations. So I'm going to write x is equal to 2 plus 22 over 16, and x is equal to 2, minus 22 over 16. The reason why we split it into two equations is because there are two solutions. There's one where we have the addition of 22 and one where we have the subtraction of 22. Keep on solving. X equals, well, 2 plus 22 is 24 over 16. X is equal to 2 minus 22 is negative 20 over 16. And we can simplify our fractions a little bit. If I were to divide both of these terms by 8 or factor out 8, reduce it by 8, whatever you want to call that, 24 divided by 8 is 4, and 16, not 8, I'm sorry, yes, 8. 24 divided by 8 is not 4, though. 24 divided by 8 is 3, sorry, and 16 divided by 8 is 2. So x is equal to 3 halves, or on the other equation, x equals negative 20 over 15. Let's divide both of our terms by, the greatest common factor is 4. So I'm going to divide both of the terms by 4. Negative 20 divided by 4 is negative 5. And 16 divided by 4 is 4. So here are my two solutions for this problem here. If we were to plug either 3 over 2, if we were to plug 3 over 2 back into x in our equation, we would get it equal to 0. If we plugged negative 5 over 4 back into our equation where we see x, we will also get is equal to 0. So we solved that all right. And that's how we use the quadratic formula to solve a quadratic equation. All right, next bit, solving quadratic equation by completing the square. So I have a few problems for us to practice here. I think I'm going to need more room. I already can tell. How can I move this down? I'm trying to move it. It's not letting me move it. All right. Huh. Sorry, momentary. Okay. Easy fix. Rotate this. Bring this down. A little bit more down. Too far down. All right. Okay, back to it. Topic 3, solving quadratic equations by completing the square. For each of the following, fill in the number that completes the square, then write the trinomial as a product of two factors. So let's start with 1. The way to complete the square. To complete the square, we take, and remember, this is the b, this is b right there. We take, okay, I feel like there's a better way to do this, but to complete square, complete the square, we're going to do b divide by 2, so half of b, and then we square it. And this is what we add to that empty spot right there. So our value of b in this problem is 14, right? B is equal to 14. So we're going to do 14 divided by 2, and then we square it. So that's 14 divided by 2 is 7. 7 squared is 49. So that's what we're going to add back into our equation. X squared plus 14x plus 49. And that's the general form. Here's the general standard form. The other form is the factored form. To factor this one, it's actually going to be really easy. What it looks like is two parenthesis sets, right? A parenthesis set being multiplied by another parenthesis set. I know they're going to start with x. What I have to decide is these two things. I'll show you how to use the x factor thing again, but spoiler, we already know the answer. Remember, we put 14 down here, 49 up here, and we need to find two numbers that multiply to 49 and add to 14. The two numbers that multiply to 49 and add to 14 are 7 and 7. So what I do is I'm going to add 7 here and add 7 there. This also looks like this is a perfect square right here. This is a perfect square. I'm going to erase this real quick and write, this is the same thing as writing x plus 7 squared. And that's the factored form. Okay. I don't like that. I want it to be factored form. Sorry. All right. And that's easy. The spoiler was when we took half of b right here, when we took that half of b, 14 divided by 2, and we got 7, and then we squared it to get 49. Well, when you take half of b, that's what the factor is. The factor is going to be whatever half of b was. In this case, it's 7. Let's do another problem real quick. For number 2, again, we have to do b divided by 2 and then square it. And that's what we put here. So in this case, b is -4 because it's -4x. So -4 divided by 2, and then we square it. That's equal to -2 squared, because -4 divided by 2 is a -2, because one's a negative number, one's a positive number. And then we square it. -2 times -2 is +4. So that's what we're going to add. We're going to have x squared minus 4x add 4. I already told you the spoiler. When you take half of b, that's what's going to be in the factored form. It's going to be x minus 2 times x minus 2, which is the same thing as x minus 2 squared. Easy peasy, right? If we were to solve these by completing the square, if we were to solve and we wanted to solve for the value of x, I'll do it for number 2. I'm not going to do it for number 1 because there's not enough space right now. But what you do is you just set this equal to 0. So I'm going to set this equal to 0. I'm going to write x minus 2 squared is equal to 0. The way we undo the squared thing here, the exponent of 2, is we need to take the square root of both sides. The function square root undoes the exponent 2. So then what we get is we just get what's inside the parentheses. We get x minus 2 is equal to, and the square root of 0 is actually just 0 because what times what equals 0? 0. What times itself equals 0? 0. And the last little bit is to add 2 to both sides because we want x alone, and x is equal to 2. So that's how we would solve that one. Here, right here, x minus 8 squared minus 64 is equal to 36. This is another kind of problem that we might see for solving a quadratic equation by completing the square. Well, the square is already complete. Here's the completed square. You can see it. It's x minus 8 squared. That's a complete square because it's the same factor multiplying itself. The way we now solve for this, the way we now solve for this is we need to get x out from all of the junk that's happening to it. There's so many things happening in there. And what we're going to do is we're going to do the reverse of PEMDAS. You probably remember PEMDAS. It's the order of operations. And we're going to go in the reverse order. So I'm going to ask, do I see any addition or subtraction that's not in the parentheses? Any addition or subtraction that I need to undo? There's my subtraction. I have this subtract that. To undo subtraction, we use addition. So I'm going to add 64 to both sides. This will undo the subtraction that's happening between here and here. And that will cancel out. So now we have x minus 8 squared is equal 36 add 64 is 100. Okay, I had just talked about this. How do we undo this squared here? How do we get rid of the squared, the power of 2 that's happening to our quantity of x minus 8? Well, we have to use the square root of both sides. The square root undoes the power of 2, and we are left with what's inside the parentheses, as in x minus 8 is what is remaining. And that's equal to plus or minus 10, because the square root of 10 is either positive 10 being multiplied by itself, which is 100, to give that 100 inside the square root, or negative 10 being multiplied by negative 10 will give us also a positive 100, which is inside the square root. Okay, the next bit is we still have x subtract 8, and we want x alone. So we're going to add 8 to both sides. And you're going to see me do something that will probably make sense. X is equal to, and I'm going to write 8 first, plus or minus 10. It makes sense to put whatever you're adding to something where you have plus or minus on one side, it makes sense to put it beforehand so you don't get confused, because this plus or minus 10 add 8, I mean, I guess that's fine, but this is a better way to represent it. Okay? So the last bit is to, again, split this up. So I'm going to have x is equal to 8 add 10, and x is equal to 8 subtract 10. Well, x is equal to 8 plus 10 is 18. X is equal to 8 subtract 10 is negative 2. And those are my solutions for this problem right here. I'll do like a little, so you know that that's another problem, just a different kind of problem, but same topic of using completing the square. Okay, pretty easy. We're going through pretty quick. Let's keep going though. All right, number 4, topic 4. Use the algebra tiles to write 2 equivalent equations, one in the general form and one in the vertex form. Okay, then find the values of x. Remember that in order to solve, the y has to be equal to 0. Okay. So we have this algebra tile, this blue algebra tile. So I'm going to set that up right now. I'm going to set up my blue algebra tile. This is x squared. The only way I can get x squared is I need to multiply x times x. This x and this x multiply together to produce the x squared in the blue tile. I have 4 green tiles. What I'm going to do with these 4 green tiles is I'm going to evenly distribute them to both sides of my square. So I'm going to put 2 on this side, and I'm going to put 2 on this side. Each of these represent 1x. So I've accounted for this, I've accounted for those. I also have these yellow tiles, and I only have 3 of them. So I'm going to draw 3 of my yellow tiles that I have, and they all represent 1. Remember how I had these 2 x's out here that multiplied together to produce that x squared? Well, we also need to add something here and add something here. What I'm going to add here needs to be x times something here will make the fact that we have 2x here. So x times something will make 2x. The only way I can make 2x and multiply to 2x would be x times positive 2. Same thing over here. I'm going to make a positive 2 over here because I have this x multiplied this positive 2 to make these 2 x's that you see right there. Okay. But look, we're missing something right here. We're missing a tile. Missing 1. Since we're missing 1, that is basically we are -1. We're down 1 yellow tile. So that's something to know. What we do now is we're really close to being done. Is we need to write them in the 2 forms. So for the general form, you look at everything that you're given in the tiles. That's the general form. It's super easy. We can either just write exactly what we see here or write what we already drew inside here. So I see x squared, 1x squared. Wait, I want to do this in a different color. I see x squared, 1x squared, plus 4x plus 3. That's the general form. Super easy. The vertex form is everything that you see on the outside here, and if we're missing or if we have any additional things. Okay, so this x plus 2 is being multiplied by this x plus 2. So I'm going to write x plus 2 being multiplied by x plus 2. And I'm also going to say subtract 1 because we were missing that 1 right there. This could also be written as, remember how if it's the same thing in the parentheses sets, we can write it as x plus 2 squared because it's a perfect square. And this is minus 1. So that's how we write it in vertex form. Last but not least is to find the value of x. So to find the value of x, and we just practiced this skill, I'll move this a little bit down, we have to set this equal to 0. So I'm going to say 0 is equal to, or no, I'm going to do it the other way. I'm going to say x plus 2 squared minus 1 is equal to 0. I'm going to add 1 to both sides to cancel that out. So then I have x add 2 squared is equal to 1. Remember to undo the squared, we take the square root of both sides. And that's going to cancel that out. So then we just get x add 2 is equal to plus or minus 1. because the square root of 1 is 1, as in what times itself will give us 1, either positive 1 times positive 1 will give us 1, or negative 1 times negative 1 will give us 1. Last little bit, subtract 2 on both sides, and we get x is equal to negative 2 plus or minus 1. I'm going to take this up here, and I'm going to split it. I'm going to have x is equal to negative 2 plus 1, and x is equal to negative 2 minus 1. X is equal to negative 2 add 1 is negative 1. Negative 2 minus 1 is negative 3. And those are my two solutions for that problem there. Sorry, that was being really weird. Okay. And that's that for that problem there. I'm going to show us how to do number 2, just because number 2 is a little bit different, not too different, but something that I think is important to know the difference, okay? So the thing about number 2 that's already different is before we were having these green X bars that were positive, but in number 2, we have these red X bars, and they say negative on them. So that's a big tell. What I'm going to do is I'm going to set up my square. Here's my blue square, my X squared. And on the outside comes x and x, because x multiplied by x will give us the x squared on the inside. I have 4 of these red tiles that are negative x, so I'm going to put 2 on both sides, just like before. 1, 2, 1, 2. This is negative x, this is negative x, negative x, negative x. So this total is negative 2x. This total is also negative 2x. So that means here I'm going to write negative 2, because this x times this negative 2 will produce that negative 2x. This is negative. That's the difference. This is negative here. We're not adding 2 this time, we're subtracting 2. The other difference that I see is I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I see 10 yellow tiles. So I actually only need 4 of those tiles here, and I'm going to have an extra 6 tiles, right? Because I have all these tiles. I have an extra 6 here, so that's add 6. Good thing to know. What we're going to do now is we're going to write our general form. General form. And remember, that's just counting everything that we see here, or everything that we see that I just drew, which I drew all those things right here based on what I saw right here. So I see 1x squared. I see 4 negative x's, and I see plus 10 yellow tiles. There's my general form. For my vertex form, remember, that's what's on the outside in the black that's being multiplied together to create what's on the inside. That's going to be the x minus 2 times the x minus 2 plus the additional 6 that I have outside here. Remember, before we were missing a tile, so we said subtract 1. Now we have all these extra tiles, so I'm adding them. And remember, the other way to write this is x minus 2 squared, add 6. Okay, to solve for this one, if we were to solve for this, what we do is we set it equal to 0, right? We say x minus 2 squared, add 6 is equal to 0. I'm going to subtract 6 from both sides, and I have x minus 2 squared is equal to negative 6. Okay, what's going to happen is sorry, I'm just thinking. Yep, what's going to happen is I need to take the square root of both sides, right, to get rid of my squared function there. And I get x minus 2 is equal to whatever the square root of negative 6 is. This should be an alert here. Whatever's in the square root, whatever's under the square root, under that radical sign, should be a positive number if it's a real solution. It should be a positive number in there. It should not be negative like it is now, because what multiplies together is what is in the square root, right? Let's backtrack. Square root of 4 is 2 times 2, or negative 2 times negative 2. But this 4 itself is positive. There's no way we can ever multiply to a negative number in the real solutions. There's no real number that multiplies by itself to give a negative number. So already I'm going to write no real solutions, okay? Because there are no real solutions. There's no real numbers that will multiply by itself to produce a negative 6. So I'm going to stop there, and we can't solve for the actual value of x because there are no real solutions. Okay, last topic, number 5. I'm kind of rushing through because I have to leave soon, but we're almost there. Solving quadratic equations by completing the square when a is greater than 1. Before these problems, a was equal to 1 because we only had one blue tile. We only had one, or even up here, the value of a, what's being multiplied to our x squared term, they were always 1. No coefficient before. But in this one, number 4, I see that the value of a is actually equal to 2. The coefficient of our x squared term is 2. So it's a little different, and we have to figure out what to do. This one is going to be confusing, so bear with me and rewatch this section if you need to. Okay. What I'm going to do is I'm going to focus just on the first 2 terms. I'm focusing just on these 2 terms, and I'm going to say, what is the GCF? GCF of 2 and 4. The greatest common factor of 2 and 4, well, what are the factors of 2 and 4? What are the numbers that multiply together to produce 2 and 4? The factors of 2 are 2 and 1, 2 times 1. The factors of 4 are 2 times 2 and 4 times 1. So the greatest common factor of 2 and 4 is 2. So I'm going to divide out that by 2. Let me show you. I'm going to show you the first equation, 2x squared plus 4x minus 3 equals 0. I'm just going to ignore this over here. I'm just going to ignore that for right now. And what I'm going to do is I'm going to divide both of these by 2. That 2 is going to come out here, and it's going to look like 2 times x squared plus 2x plus something. This is where we're going to complete our square. Minus 3 is equal to 0. So this is where we need something to complete the square. We don't know what yet, but we're going to get there. Now we can use our same thing before where we did b divided by 2 squared, and we plug that in there. In this case, b is equal to 2, so 2 divided by 2 squared is 1 squared, because 2 divided by 2 is 1, and that's equal to 1, and that's going to go up there. So our expression reads 2x squared plus 2x plus 1, subtract 3. But wait, we changed something to our equation on the left side, but we didn't account for the right side. It's no longer equal to 0 because what happened is when we added this 1 to complete the square, we didn't just add 1. Remember that there's this 2 out here, and this 2 is being multiplied by the entire quantity of the parentheses. So really, this 2 and this 1 are being multiplied together. So we did 2 times 1, which is 2. This is what we added. We added that. We added 2. So we need to add 2 to the other side as well. Because we added 2 to the left side, we need to add 2 to the right side. So that's why I put that 2 there. And I'll say, okay. So we're almost done. We're really, really close. The last little bit now would be to kind of clean things up. So this inside the parentheses is a perfect square. We just created that perfect square. This looks like 2 times x add 1. Remember how the factor, what goes in the parentheses set, the double parentheses set, is b divided by 2. b divided by 2 was 1, so that's where this 1 came from. Minus 3 is equal to 2. I'm going to subtract this 2 from both sides so we can have it equal to 0 because that's what we're used to. 2 times x plus 1 squared minus 5 is equal to 0. Okay, so that's the vertex form. The completed square of our original equation for number 4. But let's solve for this. So if we have 2 times x add 1 squared minus 5 is equal to 0. Okay, now we got to solve. Remember, we add 5 to both sides to get rid of that 5 and put it on the other side. Not get rid of, but you know. We're going to reverse PEMDAS, so we undid the addition subtraction. Now let's undo the multiplication. Let's divide by 2 on both sides. So now we have x add 1 squared is equal to 5 over 2. Because those canceled out, that canceled out. To undo the squared term of x plus 1, we take the square root. And that will cancel those out. So now we have x plus 1 is equal to, the thing about the square root is if it's not a perfect square, like if it's not a perfect number that can be a whole number, we're just going to leave it in the radical sign. That's allowed. So I'm going to leave it as plus or minus the square root of 5 over 2. Oh, that's x plus 1 is equal to plus or minus the square root of 5 over 2. Last little bit is subtract 1 from both sides. So x is equal to negative 1 plus or minus the square root of 5 over 2. Okay, and that's our answer. That's the solution. I don't like that circle. That's the solution for that problem. You can find the value of the square root of 5 over 2, but unless it asks you for a decimal and unless it asks you for like an approximation, you can just leave it as just that. And that is how we solve quadratic equations by completing the square. Let me show you real quick, I think I have time, how this would look if we were using our tiles. Do I want to show you that? No, I don't want to show you that. I'm sorry. You don't need to. If you can do this, then that's fine. And that is enough for me. All right, so that is all I have for you all today. I hope this was helpful. I hope you are able to use this and do really, really great on your test, either Thursday or Friday. Let me know if you need anything, and best of luck to you all. All right, bye everyone.